Hi guys, your Friendtor Gopika is here, and finally we have arrived at the last topic of this chapter, that is theorem of areas of similar triangles. Okay, so without wasting time, let's get started. Alright, so let me choose a pointer. Okay, so let's read the statement first. When two triangles are similar, the ratio of areas of those triangles is equal to the ratio of the squares of their corresponding sides. Okay, so if you see, these are two triangles, triangle ABC and triangle PQR. Both of them are similar triangles. Okay, triangle ABC is similar to triangle PQR. That means angle A is equal to angle P, angle B is equal to angle Q, and angle C is equal to angle R. And one more thing, the corresponding sides ratio of the corresponding sides of the triangle is also constant. When we say two triangles are similar, we know these three things. That is, first we know that all these corresponding angles are equal, and then we know that, see here I have written the ratio, corresponding sides are in same ratio. Okay, so these two things we know. Next, what we know is we drew a height of this triangle, that is AD, perpendicular to BC, and here also we drew height of this triangle PS perpendicular to QR. Okay, that's it. Now to prove area of triangle ABC upon area of triangle PQR, okay, so we are proving regarding the ratio of the areas of these two triangles is equal to squares of their corresponding sides, ratio of squares of their corresponding sides. So AB and PQR corresponding sides, their square, BC and QR are corresponding sides, their square, and ACP are corresponding sides and their square. Okay, so by this theorem we mean to say if we have two similar triangles, then the ratio of their areas is same as the ratio of the squares of their corresponding sides. Any corresponding sides you choose and square it, then the ratio will be same as the areas, ratio of the areas. Okay, so if you observe this part, if I forget this area part, then this part is already trivial. Trivial means this is already we can say it can be easily proved. Now if you notice over here, when two triangles are similar, we know that the corresponding sides are in same ratio, correct? Now if the ratio is same, I can square this, still the equality will be same, correct? After squaring, what I will get? AB square upon PQ square is equal to BC square upon QR square and is equal to AC square upon PR square. Okay, so this part is actually trivial. That means it's very much simple to prove, or it is evident that it is true. But only one part in this theorem we need to concentrate is, if we prove this area of the ratios of areas of these two triangles are equal to one of these ratios, just one, if we prove, the rest will follow as it is because of this fact, since the ratios are same. So we have to prove that ratio of areas is equal to one pair of corresponding sides. The rest two will follow. Once we prove one, the rest will follow. Okay, so here one of them will prove and the rest will follow naturally. So let's see. Now if you observe, area of triangle ABC upon area of triangle PQR is base into height, just applying the formula. So base into height means for ABC the base is BC, height is AD. Similarly in the denominator for triangle PQR, base is QR and height is PS. Okay, so this we learned in the very much beginning of the chapter, that when we have two triangles and when we want the ratio of their areas, if the height is same, then the ratio is same as the basis. If the base is same, the ratio is same as the height. And if we don't know if the base or height is same, then it is product of base and height, correct? So same thing we have applied over here. Now I just wrote it separately as BC upon QR into AD upon PS. You will understand as we go further why we wrote it like this. Okay, now my aim will be, or our aim will be, to prove that this AD upon PS is same as BC upon QR. If I prove so, then I will get area of triangle ABC upon area of triangle PQR is equal to BC upon QR into BC upon QR. That will be BC square upon QR square. Okay, so our aim is to arrive at the fact that AD upon PS is same as BC upon QR. So let's see how we arrive at it. Now in triangle, now we observe this. Once we drew the height AD, there is a triangle formed over here ABD and PQS. If you observe, these two triangles are similar, and this we can say by AA test. Why? Now we know that angle B is same as angle Q, correct? And one more angle that we know is 90 degree. This angle ADB is equal to angle PSQ is equal to 90 degree, and second angle is angle B is equal to angle Q. So by AA test, see, by AA test we have this triangle, right angle triangle ABD is similar to the right angle triangle PQS. Once they are similar, let's find the ratios. So AD upon PS is same as AB upon PQ. Okay, why we chose AD upon PS? Because that is what we have trying to find if it matches BC upon QR or not. Okay, so AD upon PS is same as AB upon PQ. Now since ABC and PQ are similar triangles, this is already given, right? These two triangles are similar. So from here, if you observe here what I have written, AB upon PQ is same as BC upon QR. So same thing here they have written. Okay, so now if you observe what all you have to observe, 1, 2 and 3. So first you just note 2 and 3. From here what you can make, AB upon Q is common. That means AD upon PS is equal to BC upon QR. Okay, so from 1, 2 and 3, area of triangle ABS upon area of triangle PQR is same as, first write this equation, BC upon QR into AD upon PS. Okay, now from 2 and 3 we got AD upon PS same as BC upon QR. So replace this AD upon PS by BC upon QR. So we arrive at BC square upon QR square. Okay, so as I said, once the area is equal to one of the ratios, the rest will follow because of this. Because all those ratios are equal, the square also will be equal. Okay, simple. So what we do, first we write areas of these triangles as base into height formula. Okay, half will get cancelled, so just base into height remains, correct? Then one part of it, one is what we require, the other part also try to match to the first part. For that we consider these two right angle triangles, and we get that AD upon PS is same as AB upon PQ. Now AB upon PQ is same as BC upon QR, since those triangles are similar. So we got that AD upon PS is same as BC upon QR. Hence replacing it by BC upon QR, we get that areas ratio of areas of those triangles are BC square upon QR square. Simple. So step by step we have to go. So first write what is to prove, and then write the areas, ratio of areas as base into height formula. Then split it, then keep it as it is, mark it as 0.1. Then consider the two triangles ABD and PQS. Okay, from there by AA test we can easily make out that those two triangles are similar. Hence find the ratios and then arrive at the fact that AD upon PS is equal to BC upon QR, and then replace in the equation 1. And just that's it. Rest is very trivial. Okay, simple. Yeah, so now we will see very simple. Actually the first 3 questions of practice set 1.4 is application of this theorem, and just 2-step problems. That's very simple, so let's discuss that. Okay, so these are the first 3 problems of practice set 1.4. They are very simple, just 2-line answers, and actually 2 of them are just fill in the blanks type. Actually just first one we need to write. So let's read the question. The ratio of corresponding sides of similar triangles is 3:5. Then find the ratio of their areas. So ratio of the corresponding sides is 3:5. So ratio of their areas will be 3 square upon 5 square. Simple. Just actually applying the statement of the previous theorem. Okay, now this is true only when the triangles are similar. So area of triangle 1 upon area of triangle 2 is equal to 3 square upon 5 square is equal to 9 upon 25. So the ratio of the areas is 9/25. Simple. So let's see the second one. If triangle ABC and triangle PQ are similar, AB upon PQ is 2 upon 3, then fill in the blanks. So area of triangle ABC upon area of triangle PQR is equal to AB square upon PQ square. Okay, so AB is 2 square, PQ is 3 square. What is 2 square? 4. 2 square means 2 into 2 and 3 square means 3 into 3, that is 9. So 4 by 9. Okay, we cannot reduce it further, so this is the answer. This is the ratio. Okay, now if triangle ABC is similar to triangle PQR, area of triangle ABC is 80, area of triangle PQR is 125, then fill in the blanks. So area of triangle ABC upon area of triangle PQR is equal to 80 upon 125. So we can reduce it further. That would be 16 upon 25. With what we can divide? By 5. Simple. So if you divide 80 by 5, you get 16, and by 125 by 5, you get 25. So that is 16 upon 25. Now we need to find what is ratio of AB upon PQ. Now from this 16 upon 25, what do we know? This is same as AB square upon PQ square, correct? So from that we can get AB upon PQ. So it will look like AB square upon PQ square, because since area of triangle ABC upon area of triangle PQR is equal to AB square upon PQ square, we can say that AB square upon PQ square is same as 16 upon 25, and 16 we can write it as 4 square, and 25 can be written as 5 square. So AB square upon PQ square is same as 4 square upon 5 square. So what will be AB upon PQ? It will be 4 upon 5. Okay, simple. So once we know the ratio of their areas, we know that that is same as ratio of the squares of the corresponding sides. Okay, ratio of the squares of the corresponding sides. So AB square upon PQ square is equal to 4 square upon 5 square. Hence AB upon PQ is same as 4 upon 5. Simple. So the first 3 problems are really simple, just fill in the blanks, and the rest 4 are simple, but we need to work it out. Okay, so the 4th, 5th, 6th and 7th problem I'll be discussing in the next video. So wait for it, guys. Okay, so I'm done with this video. Okay, thank you for listening to me, guys. If you like the video, please share it to your friends, and please subscribe the Friendtor channel, and you can also follow us on Instagram. You can DM your problems or queries regarding mathematics. We will respond as soon as possible. Okay, bye. Thank you.